Okay, we're going to be looking at identify basic facts about radio theory receivers. Remember, you got to get 70% on the progress check. Now, please understand 1 Alpha, Bravo, and Charlie are still 1 Alpha. We broke them down to make it easier to segment these things out. Just makes things a lot easier in the end run. Right, looking at the AFSC, the big thing is when you are looking at a receiver, if you can't receive what you transmitted, you got some issues. Now, the reason why we're breaking these down into transmit and receive is we do have this out there in the commercial side and the Air Force side. Commercial side being things like a radio station that you're listening to on your radio. The radio station is a transmitter. What you're listening on to is a receiver. Nothing more, nothing less. Out in the Air Force, we have something called an ATIS, Air Traffic Information System. What it does is it transmits out. All the planes receive it. Get it now? And it listens to the information that is at that base. Things like, is it blowing really hard? Is there a tornado set down? Is it calm? What's my visibility? Things like that that go into those devices. So we start simple and work our way to what's called a transceiver. The overview, we're going to be looking at receivers in general, antennas, going through power supply, the RF amplifier, tuner, oscillator, mixer as opposed to modulator, detector, AGC, a little bit different than your other control circuits, audio amplifier, and signal flow on top of that. So let's go through each one of this. What the heck is a receiver? Well, if you transmitted it, you now need to recover it. You need to recover that intelligence, see what the dissonant just told you. We have the receiver components, a little bit different than probably what you're used to seeing. There's been some addendums in there. We'll go through each one of them. We have the power supply, just like the transmitter. When you turn it on, everything is going to power all the components. Now, with this one, there is some caveats to it. We forgot to tell you back in transmitter that when you turn this thing on, I think it's Airman Soto was talking about the phase lock loop. Correct me if I'm wrong. Where when you turn it on, the phase comparator is
yes,
at what the VCO and the reference is doing, and if the VCO is not on target, it's going to send an error voltage. Well, what happens when you turn it on? It's not instantaneous. It's got to build up to it. So it can take up into a couple seconds. I've seen radios that tell you that it takes a half an hour for that oscillator to warm up where it's acceptable. It just depends on what you have as far as the equipment that's out there. We look at the antenna. Again, it's a length of wire. What's it used for? I need to get that RF captured. What does it do? Well, because the transmitter is so strong, the receiver is going to end up with something extremely small. So that's the problem with the transmitter versus the receiver. The receiver, man, any wire. How many people out there have seen vehicles going down the road and has a coat hanger or an antenna? Bring back memory? Yes, it works. A wire doesn't care.
Yep.
The only time a wire really becomes a potent part of the system is when you want to get specific frequency. But for an FM radio that's in your car, coat hanger will work. So
Why did it take so long to get cars without huge 2-foot antennas that stick up? I feel like I have a 2014 truck and it still has a big old antenna sticking out of it. Like, why didn't they figure that out sooner?
An AM radio, did you not, was an option in a vehicle. An option. Not standard equipment. What you probably have, how old's your truck? Okay. And you have a 2-foot antenna on it?
6 years old. It's just, I don't know if it's a full 2 feet, but I mean, it's close to just a standard, antenna that sticks
that
out.
would make sense. If you have AM, you're going to need a longer antenna. If you had FM, you would probably need a shorter antenna. If you had, let's say, Sirius or XM, a very small antenna. And I'll explain why when we get into polarization and things like that in the 2 alpha through 4 Bravo scenarios. So what a tuner does, and again, this is on the front lines of matching your antenna to the frequency so you pull in that desired frequency and try to reject all others. And like Sergeant Pagan had said, the variable inductor and variable capacitor. He was just talking about an inductor and a capacitor. Well, if it's variable, you can change frequency and get it tuned properly. That's the manual side, or you can do it the automatic way. And we have radios that do that. When you look at the RF amplifier, first of all, I told you that, hey, it doesn't care what kind of antenna you have. We get the tuner, do its job, comes in. It's going to be extremely weak. And we'll explain why, because it takes a time period to go from the transmitter to the receiver, and there's a lot in between it that's going to make that signal weak. Well, anything, if it's weak, I got to make it strong. Use an RF amplifier. When we get into the oscillator, this is where, again, Sergeant promoted you there, Soto. Aaron Soto talked about the phase lock loop on there. Big thing, need it to mix with everything. And when we get it to those mixers, we're going to take the oscillator frequency and the receive frequency. And in this case, there's a new word that pops into play. It's called heterodyning. You guys covered heterodyning in the earlier blocks in the, I'm trying to think of the electronic ones, first couple ones? No? Okay. This is a new word. Now, you'll notice that the modulator only produced 3, and we got rid of that 4th one, which was the audio because of the impedance. But this one's a tad bit different. This one's going to give us 4 frequencies. We're going to have the actual receive frequency is one of them, the oscillator frequency, the sum, which is the combination of the receiver and the oscillator frequency, and then the difference, where we subtract the 2. We get to a detector, and after cleaning all this up, going through an amp and a filter, this is going to pull the audio out as well as some type of DC voltage and send it back to the AGC circuit for control. Yeah, it does that. It's a crazy piece of a module. When we get to AGC, because it's going to loop back around, the whole idea behind AGC is going to maintain a constant audible output with a varying RF input. What does it mean by that? Well, constant audible output. In other words, I'm not going to have to increase the voltage to hear it or decrease the voltage to hear it comfortably. In other words, one output. Why is that possible? Well, think about it. You guys have been cooped up for a while. They give you, one day on, let's say, Saturday. Hey, anybody can go, 100 miles away. Everybody packs up in their car. Everybody's listening to the radio station, the FN one. We'll go without. And they go from Biloxi to, let's say, Mobile. Okay, you're listening to the radio station in Biloxi. Are you going to have to change the volume the further away you get? No. What's it doing? Well, you now have a variable input to your radio. Why? The farther you get away, the weaker the signal. So you get the mobile, you do a little happy dance there, and then you come back. Well, now the signal is going to get stronger, isn't it? Still not having to adjust the volume control, but it's still a variable RF input. What happens? You didn't have to adjust your volume control button no matter what you did, whether you were close or far away from the radios. That's what AGC does for you. Basically a hands-off thing. When we get to our audio amplifier, after we've pulled that signal off, just like with anything, anytime we get a manipulation of the signal, especially when we break it down, we need to amplify it. Why? Because the speaker is not 50 ohms. It's normally anywhere between, I've seen low as 4 ohms and as high as 600 ohms. Most of our Air Force devices are 600 ohms. Why? Because we have aircraft, and that's what they are. They will interchange the speakers. Kind of crazy, ain't it? Called money savings. Let's look at the signal flow. Okay. First of all, power it on. Power supply is going to give power to all the circuits. Here comes the receive signal. It's going to receive it on that wire, go to the tuner. Tuner's going to select that frequency. That's the stuff that you're going to put in there, just like your radio station in the car. We're going to go to the RF amplifier, and we are going to select or amplify that frequency that we just selected. We go to the oscillator. When that power hit the oscillator, it's going to gin up. It's going to get stabilized, and then it's going to generate that frequency that I want to mix with the RF frequency. That receive frequency then is going to heterodyne with the oscillator, give us 4 different frequencies. Then we're going to go through the filter and IF amplifier because it's part of that mixer. In some instances, it is broken down into a separate module. Again, it's controlled by AGC because when it gets to the detector, it's going to give us a representation of the signal strength send up to AGC. And then that AGC is going to develop a voltage. If it's too strong, it's going to bring that signal down. If it's too weak, it's going to bring that signal back up. And then we're going to send what is left out of that detector, which is the audio portion, send it to the audio amp, by it, and then send it to the speaker. So we've gone over receivers, the antenna itself, the power supply, RF amplifier, tuner, the oscillator, as well as the mixer, detector, AGC, audio amplifier, and signal flow.